Hello everyone and welcome to a new chapter in the course INFS102 Problem Solving and Programming. So in this chapter we are going to discuss and study about the functions. Actually this is an introductory level of the function topic. So we will be studying what are functions and how are they actually making up the whole program so manageable and kind of making sense. All right, so throughout this chapter, we will be going through many points over to cover the topic of the functions. It is actually a very important topic, as I've mentioned to you in the previous classes, and you will need actually to focus more on it because in this, starting from this chapter, we will be actually opening up the programming concepts to be like more than the main function as you remember and as you have been practicing before. So first of all, we will be defining what does it mean by modular programming, and which is actually the introductory or it is we call it the prologue to introduce functions, and then we'll be defining what is the function definition and calling, also function prototype, and then how to receive and send data, how to pass data through the function. And this actually in this session I'm not going to cover the whole points here. I'll be dividing them into parts, so whereby we'll be trying to cover from point 1 until point 5 within with actually more details and examples. I will even try to make this session as like more into practical, because I think this will actually bring more benefit. This will bring more effective way of learning and understanding the theoretical points. All right, so let's just go to the first to the first point here, talking about modular programming. Okay, so when we say modular programming, it is actually a concept of breaking the program into a smaller chunks or a smaller kind of pieces of codes. So these codes, or like these blocks, they can be gathered and they can be managed under what they call function. So here, let me just bring this. Yeah. So here we talk about the functions is like a collection of statements to perform a task. A task. It is implemented. It implements the the algorithm steps. So what we have understood now is that modular programming, it is a very popular concept and it's a very generalized concept in field of programming. And so it is about breaking the program into smaller manageable functions, or like grouping the pieces the pieces of code, those who have relation with each other, into like something related. How is that being realized? It is by using what they call functions. Okay, so it is it is a motivation for modular programming. Why do we need to have modular programming? What is the advantages of having this? It is to improve maintainability of the program. So that's why modular programming here is being introduced. And it's also to simplify the process of writing program, and even not only writing, it's also even auditing, checking, and reading that that kind of program, especially when you talk about program that actually implement more than reading pieces of information, or printing out a result of a specific formula. So there are actually, there are programs that has been designed to do actually more than that. It's not only just to make one or two calculations, or like display, a certain, a certain output. All right, so take a look at this. This is what I want to show you regarding the function. So imagine that we have under the main function, because this is the function that we have studied before. This is the only function that we know. This is the place or the container where we should put everything related to the program. But imagine that now we are explaining why do we need actually to have more than one function. All right, imagine that we have actually 20 or 30 or 40 different statements of statements of programming here, and these statements happen to be so so variety. Differing. Each one is differing from each other. Like for example, the first some statements are actually to allow the user to enter data. other statements allowing the user to, I mean, like calculate a specific thing, or like calculate a specific instruction, or translate a specific instruction. So different statements are actually doing different things. So when you actually have more than one purpose in the program that it's about to do, it actually make it kind of messed up to be arranged and, I mean, like understood. So it is very difficult for us actually to even understand this. Even if you have like one error, like you're defining variables here and defining variables again here because you are using them in another way, that will be actually so messed up. So with that, I mean, like as a solution, so the main, I mean, like that program, that main function can actually allow some of the statements here to be executed in some other blocks of codes, and we call these blocks, I mean, like define these blocks by what we call function here. So we can have like function 1, function 2, function 3, but actually we cannot have more than one main. This is like from now, let me tell you. However, we still did not go in details about the function's characteristics, but let me tell you from now is that each program and each code doesn't include more than one function. I mean, which means that we have only one main function, and this function acts as the mother function that has, I mean, like relations and connections to each, I mean, like to each of these functions. Okay. Yeah. All right. So moving to the next here. Okay, so function call here, it is, I mean, like a statement. So how actually the function can be executed here? I mean, like, all right, so let's say that we have these functions 1, 2, 3, and we have the main function here. How can we connect these functions to execute them? Because finally, I mean, like at the end, the compiler needs to know that there are functions, and by placing the functions like this, I mean, like by this way, without any linkage with the main function, the compiler will not actually has, I mean, like any signal that there exists other functions here, okay, or there exists other parts of code that needs to be implemented. So let me just I mean, like put this in general. So here let me just type the functions, I mean, like all functions. Actually this is a cpp file, so let me just put it as a comment saying all functions other than the main function need to be linked with the main function in order to be executed. Alright, so here we talk about like there has to be some kind of linkage between the functions here. Alright, this is, imagine that this is actually, let me just start new file here. I'm just trying to draw something. Right, imagine this is the main function here, and you have like you have also function 1, function 2. Yeah, let's just take it enough with 2 functions here. So this is like function 1, and this is function 2. Right, so the compiler, when it comes, it doesn't matter actually, even if the function comes to be here at the end. I mean, like when the compiler starts here, okay, so imagine that these functions are actually really, I mean, like resides under, I mean, like this is the whole program. Imagine that this is the whole program. So let's say like here we started by including, I mean, like I started by typing what they call here, started by typing include IO stream, and then using namespace std. Okay, imagine that this is actually the whole, I mean, like program, and it happens that there are actually some functions beside the main function. So when the compiler comes here, it actually at the beginning, what it actually do is that it looks where, I mean, like where is the main function located. So if the main, I mean, like it goes and identifies that line that starts by int, that starts by int main open and close brackets, and then actually executes whatever, I mean, like codes inside that function. Then it goes, I mean, like into the rest of the program. So how it knows without, I mean, like without linking these programs, okay, without linking these programs into, I mean, like the main function. Let me just look for the specific. Hopefully, this could help. Without linking these functions into the main function, actually we will not be able to to execute them. Okay, so thing is that actually we need to have a linkage between the functions here. So we need to have the main function to, I mean, like the main function to have part or something that that actually allow the other functions to be executed, and this is what we call by, I mean, like the linkage here. The linkage is called the function call. Okay, so this linkage that we talk about, I mean, like this kind of linkage that allows the other functions to be linked in the main function, we call this as the function call. So the function call here, I mean, like turning back to the slides, and the function call here is that statements that happen to be either in the main function or in another function. But actually, I mean, like in most situations here, it has to be in the main function. Why? Because the main function is the main, I mean, like it is the first piece of code, or it's the first block of the program that the compiler will look into. So the program will look here into, I mean, like the whatever code has existed here. So if these functions exist, then they have to be linked by kind of a statement here. So this statement is called function call, and its purpose here it is to enable the execution. It is to enable the compiler move from after here. I mean, like whenever the compiler reaches to that particular statement, it actually moves into the function, whether function 1 or function 2 or whatever function that has been defined, execute its body, and then get back to the main function and continue the other, I mean, like with the other calling. If there is another calling, it goes to the second function, for example, and executes its body, and then gets out of that function, going back to the main until it reaches where, until it reaches actually return 0. And we will talk about this. Actually, we will have a lot of discussion about this. I mean, like why now we will discuss why do we have why do we need to write return 0 here for the main function. Okay. All right, so like this is the logic here, and we call this as the function call. Right, so we have another term here that is called function definition. So function definition is the statements that makes up the function. It is actually like the variable definition. So most likely, I mean, like during the, I mean, like when you studied the variables in chapter 2, you remember that we need to define the variable before we use it. Same things, the same thing goes for the function here. It is like when you, I mean, like when you type int, for example, int x, okay, yeah, int x, that's it. So this is a variable definition. I mean, like what we have done here, it's just a variable definition. Same goes for the function here. So if I can mark this as a variable definition, I can say that the function definition here can be like as simple as int. For example, let's just use the one that we are used to. I still do not want to go into details with this later on. I will show you the other kind of definitions. Let's just assume that int main here, this is the definition. So it's open and close brackets. So until here, what we have done here, until here, this line of code here, it is we call it a function definition. Okay, so this is very simple. So it's just the type. We call this the type of the function, and we will learn actually more than one type of the function, and even you will see this later on in the next coming few slides. And then the name of the function, and of course this is the parameter scope. We will call this the parameter scope, and later on we will also know how to handle this. Okay, so by then we have defined the function. So remember, of course, so here as I told you, this is just very similar to the variable definition. It has like the same format as the variable definition. Okay, so there are some notes here that we need to define, like that we need to know, that we need to consider whenever we are defining, I mean, like functions here. All right, so the first one here, it's called the first one here is called the function name. So name of the function here is the name of the function, or function names follow. The name here, it actually represents the function name here. It could be int main, could be like int sum, it could be whatever name it is. So this is up to us, unless, I mean, like, only thing that we cannot change is that main function naming. Okay, so each program have to have at least, it has to has at least like one main function, right? And other functions, yes, we can actually change them according to, I mean, like, as I mean, like, the same thing as we treat the variables. So we can put it as int x, int sum, int whatever name it is. But again, I'm saying, if you remember how do we define the variables in a much better way, is that the name of the variable have to reflect its content, and also the same thing, the name of the function has to reflect its content. So if we define the function name here as sum, so of course we are expecting that, I mean, like, whatever contents here, they should, I mean, like, it should actually handle something like x plus equal to 5 plus 6, as to be very simple example, or at least to print out something, or to do, I mean, like, something related to, I mean, like, the name. Then the parameter list here, it is actually variables that holds the value passed to the function. This is the parameter list here. We will not, I mean, like, this function now, the main function, is actually a function that has no parameters. Even this function, the function has no parameters, but later on we will introduce you how to use the parameters here. I mean, like, within the function itself. And then we need to know that there is also the body of the function, which is this one. So the body of the function, it's actually the piece of code that resides between the open and closed curly brackets. So we call this as the body of the function. So let me just hint this again here. So here starts the body of the function. Okay, so we can I mean, like, use it as, I mean, like, we can comment it as this way. And then also the return type here, whether you have like an int function, or like another function, another type of function that doesn't return, so whether the function is returning a value or not. So we can decide, we define this. So for types of, I mean, like, int or double, and later on we will discuss about this more. There is one type of function that can return a value, which is this one, actually, this kind of function that has the, I mean, like, the data type here. And then at the end we should actually write return whatever variable you want, or whatever value, return 0, return x, for example. And later on we will discuss this, actually, we will discuss about this later in more details. So it's a data type of the value the function returns to the part of the program it is, I mean, that calls it. Okay, so this is again what I'm trying to explain to you here. So the return type here, and this is the name of the function, and this is actually the parameter list. So this one is already empty, and this is the body of the function. And here, of course, you'll be having the, I mean, like, the returning, because this one, since this one is a returnable function, so it has to return something. Okay, so okay, now we need to know something here, is that the line that reads int main here, it is called the function header. So remember this. So I mean, like, the whole term here, we call it as a function header. Okay, it's the head of the function itself. All right, so function header here again, it consists of the return type, which is this one, int, double, the char, or even non-return type, we call it void, and later on you will see it. And then we have the function name, and then we have the parameter list. So 3 things that can be included in the function header, and you need to remember these. So for example here, int main, you see, and note, we do not have any semicolon after the end of the header. So it is wrong to type it like this. That would be very wrong. Okay, so we do not add, I mean, like, semicolon, but rather, of course, we add open and close brackets, and within these we have our code, as you will see, as you can see. Okay, so all right, so the return function type here. So okay, now we are actually introducing, I mean, like, both of the the function types in terms of returning value. There are some functions that are returning values, and these functions are actually well known. Some I mean like some kind of end function. I mean like something like end function here. It returns. So whatever value here comes in the main function at the end. So this is the return value of the function. All right. So you need to know this. So whenever the function has any data type like int, double, or char, or string, okay, so of course it has to return value, and we call this kind of function is a returnable, a function that returns a value, or a returnable function. Okay, so there is another type of function that is called non-returnable function. That function actually doesn't return any code, doesn't return any value. That does not return any value. Okay, so this kind of function, it can be represented instead of int or double, it is represented by the keyword void. So void, and then plus the function name could be display, for example, value. Okay, and the parameter list, open and close brackets. Okay, so all right, so one of you, one of you may ask, why do we need actually to use the, like the non-returnable function? If we have actually one int, like one function like int function, why do we need to use like the void function here as to be another kind of non-returnable function? All right, so these kind of functions are usually used only to display, okay, or only to calculate, just to calculate or like to display. And most likely, especially in your level of learning in this course, you will be using that for that kind of function if you just want to see out something, see out, for example, hello world, okay, hello there. So this kind of this kind of function is actually performing these kind of programming statements, and rather they do not actually return any value. Okay, so then what about the other values? Because some of you also may ask, even we have seen this, but we didn't use it at all. It is because this one actually from the system. This one has to be there from the system, since we are talking about the main function, okay, as a returnable type of function. But if you talk, if we create another kind of function other than the main function, like for example int, let's say sum. If we're using like int sum, for example, function name here, and here open and close brackets. So here inside that function, I want to calculate int, for example, x equal to what? As simple as possible. That will be 3 plus 1. Okay, and here I have to return one value. Either I have to return, most likely I will be returning x, which is whatever value that I'm calculating here, because this function, it is to do some operation, and the operation here happened to be the sum operation, and the result of that sum operation will be stored in that variable. So here I should return some, the value of x. So what does this mean is that whenever this function is called, and later on we will see this in practice, and we will see this in the compiler also, whenever this function is called, it will actually return the value itself. It will not print it out. This does not print the value of x, but it only returns it. What does it mean by return? Return later on, like in the main function, when we call it here, okay, so we can assign the value of, instead of performing the whole code here inside the main function, we can only just call this function and then assign something like y equal to whatever, the function name here. And later on you will see, because we can now handle this function as one value. Like we can look at this function as one value of a variable, or like one value that we are actually calculating and returning. So a function, this kind of function is actually calculates, do some operation, and then returns that value. So it can be int, it can be double, it can be actually any kind of data type. But remember this, and from now on, I will tell it to you, is that of course the type of the function has to be exactly same as the return of the return type, because the return type, it can return any variable within the function. It can be, maybe we can have like another variable. If you have another variable double, for example, y equal to t equal to, for example, 6.8. Okay, so here it's up to us what kind of variable we want to return. So it depends on the variable that we are reading here, actually. Okay, so if you just want to return this variable, so here, of course, the type of the function here, or the data type of the function, has to be, or the return type, we call this the return type of the function, has to be same as the variable data type. So if this, if the variable data type int here, of course the return type has to be int in the function. If it is actually t, then we need to change this to be into double. Okay, we need to change this to be into double in order to match with the returning value. I hope this could be very clear to you. Maybe I'm just taking to you into more details from now, but actually things are really connected to each other. So from now, let me just clarifying them to you, and later on, of course, we will just go through them again and again and again. But here I'm just talking about the types of the functions. So here we have understood that there is, in terms of returning, we have two types. The first one, the first type, it is that functions that return value here. So whenever you see the return keyword here, you will understand that this is the kind of return function. Other functions is that these are the functions that doesn't return any value. So these are the functions that whenever you call them here under the main, is that they will only be executing its body. Whatever, see out here, it will be executed. All right. So here we do not have any value from the functions, but here, of course, we are seeking one value. We can actually assign y equal to the value of the sum, for example, okay, between two brackets. We can do that. So it's now y, the sum value here, or the sum, it can be actually, it can be imagined, or it can be assumed as the whole value that the function is returning, assuming that this is actually returning an integer value, of course. So this is actually what it represents. So the value of sum here, that would be 4. So it is another representation of saying that y equal to 4, right? So here, the sum here, it indicates the value of that return. Okay, so this is the thing that actually being implemented in the return value. Let's just go back again here. All right, so if the function returns a value, the type of the function must be initiated. For example, here, because the main is returning 0, of course we need to return the type of the variable or the data that we are returning. Since the main is return 0, 0 is actually an integer, so we can return, the data type of the function here has to be int. But if the function doesn't return any value, as we have talked just now, so then we can call the function type is void. Okay, so void here, it's used to indicate that the function doesn't return any value. For example, here. Okay, so it's just as I told you. So these kind of functions are actually used to print, usually to print out something or to display some, some text. Okay. All right. So a function calling is to call. To call a function here, we use the function name followed by the brackets. Those kind of brackets. So, for example, print heading. Okay. So this is actually how we call it, and most likely these functions. Let me tell you about. Let me speak about about your level of learning now. Whenever you're calling function, you're actually calling functions into the main. Okay. Okay. There are actually coding inside another functions, but for now you'll be calling functions into the main. But maybe later on during the lab practices, because that time will be more into programming, more into practical. Maybe you'll be introduced to call functions from another function other than the main function. Okay, so when a function is called, the program executes the body of the function. Then this saves a lot of redundant coding. So for example, here, instead of duplicating the same code, too much duplicating the same code in the main function here, you can actually just use, for example, here, let's say that you're actually doing some kind of sum operation here. Okay, and in the sum operation, you're asking the user to enter cn, for example, a value. cnx, for example, or cnt, and then you're using actually this has to be here, for example, to indicate you what I'm trying to do here is that I'm indicating that there is double, no, that should be mt, and then read t, and then you are using actually t here inside x to calculate, to calculate the x plus t, as simple as this. Okay, so if you want to actually if you want to to make this calculation more than one time in the main function, what you need to do, the traditional way here is that you need previously, without having other functions, without the knowledge of having other functions existing, is that you should copy this code as many cases as as many times as possible if you want to perform like different types of if you want to read different types of x, okay, or like if you want to perform that code more than one time. But using the function here is that you can call the function name and its code will be executed. So instead of having 3 lines of code being typed each time, you'll be only typing like only the function call here. All right. So that's actually what it means by saving a lot of redundant code. So we do not need to repeat the same code. So after the function terminates, executes, resume calling module at the point of the call. All right, so calling a function main is automatically called when the program starts. So as I told you, the first function that the compiler looks at here, it's the main function. So this is the first function to be executed. Then main can call any number of functions inside it. So the function can call another functions also. Okay, so you need to remember this. So main function can call any number of functions, and even within the functions themselves, they can call other functions. All right, so calling a function here, the compiler must know the following about the function before it's called. It has to know what are the information that must be known in the function. It has to know the function name. It has to know the return type. This is the function name, and then the return type, for example, before it's called, meaning that, and the number of parameters, and then the data type of each parameter here. Okay, so all right, so imagine that we are actually going through the first program here is that we are trying to display something, okay, from the main function. So we are creating main function, and then we want to create another function that's linked to the main function. Let me just go to the compiler here and do some practice. All right, so imagine this is the main function. Okay, so let me just delete the main function even, because I will start from the scratch here. Okay, so typing main int main, and then I'll open and close brackets here. Of course, under main you need to type the return 0. And I want to tell you this. Always in the main function, we only return 0. Okay, unlike the other functions that have the data type of that have a returnable data type, is that we may need to return any kind of variable name. But in the main function, we only return 0. It's because we need to indicate that everything in the function or all the code is being executed correctly with no errors. This is kind of a message to tell the compiler that everything. There is no kind of errors all in this function. Okay, so here we need to write another function that is called void. So this is the data. This is the return type of the function. So void meaning that it doesn't return anything. Void, and then the function name display value, for example. And then this is the parameter list. We do not have anything in the parameter. And then this is the body of the function. Okay, so inside that we can type cout, for example. I like programming. So that should be the message here. So I have another function that only has that message. Okay, so now how can I call this function? If I executed this now, and I will tell you now I don't have anything. I just have a main function, and even in the main function, let me type cout function. Cout statement says that hello from the main function. Okay, and let me just execute this and see how many C outs will be executed. Hello from the main function only. Then what about that one? However, it's already existed here. It seems that the compiler doesn't look at it at all. Okay, so this is because we do not connect this. We don't yet we have not yet connected that function into the main function. So now when the compiler comes here, it reads that okay, so this is the main function, and there is actually one statement here, and that's it. So the statement here has been executed, and this is the output. And then the return function indicated that this is the end of the function with no errors. Okay, and then that's the end. So it seems that even whatever function exists here, even though that the code there is a C out coded but doesn't actually appear, it's because these functions or this kind of function it's not connected here. So now we have to use what we call the function call. Okay, this is the one that we mentioned here just now. Okay, so now we want to write something called like as the function call in order to make this function reachable to the compiler. So function call here, it is like to write the name, display value. It is just to type the name of the function, display value, and we use the semicolon here. Okay, so this is it. But now we have one problem, is that the function here has to be defined. It has to be defined before it's used. Okay, so let me just execute this code, and I will show you that there is an error here. The compiler will not be able also to read this, and it will display that there is an error. Okay, so executing this code here, it indicates yes, there is an error here. So what kind of error is that? It says that this function is actually not being declared in this scope. So meaning that the compiler, when it comes here, it reaches up to this level and it says that okay, so display value seems that this is a function, but where is the function? It is not being displayed. So it has to be defined. So definition of the function, meaning that this one, which is the function header. So in order to make this code executable, like in order to tackle this error, to solve this error, we have to place this function before the main, which means that here, so I will write this as comment. So each function has to be defined before it is called. I hope the text color could be kind of readable here. So each function has to be defined before it's called. So same as the variables here, we cannot actually execute the variable, or we cannot say that C out x without actually defining what is x, int x, double x, int x equal to 3, for example. Same goes for the function here. It's the same actually idea. So we have to place the function, any kind of new function here, it has to be placed before it is called. Later on, we will learn one mechanism or one method that actually enable us to place the function in anywhere, any place in the code, even underneath the main, below the main, and we still be able to execute it. But for now, this is what you need to know. So let's just execute this code and see. So now, yeah, so here you go. So now, hello from the main function, and then I like programming. So, and you can see that. So what happened here is that compiler has gone into the main function, executed that code, and then looks into the display value. Oh yeah, so display, it's already been defined here. So the compiler already have some information about the display as what I have been telling you. So the compiler must know the following about the information before it's called. So meaning that this is the a proper place that the information can get the whole that the compiler can get a whole information about the function that we are calling. Return type, as you can see it, the name, the return type, number of parameters, and also the parameter types. Okay, so and then so after it executes the code, so does it end here? No, it comes back to the end, but because at the end we do not have anything after executing this function. But imagine if we have like C out, um, um, I am back to the main function. Let me just put this in a new line and execute the code here. Oh, the code doesn't execute. Okay, let me just execute the code once again, and there you go. See? So processes like this. Number one, it was reading. I mean, the compiler comes into the main. It reads actually it reads the first statements, which is the display hello from the main function, and then it goes out of the main into another function after that function has been displayed, after a function that has been defined properly. Then it executes its code. So it is called here. It only includes one cout statement. If we have two, three, four cout statement, even if we have like kind of if we have kind of I mean like calculation here, and for example, int x equal to 6, and then we want to display again here. This is also x, for example, okay, and end line. You can do so actually, all right. And then so whatever calculations, it reads that calculation and then executes it and then returns back to the main. Okay, so let me just try this new modification and tell you how is it going on. See, so this is the thing. So hello from the main, I like programming, and 6 also has been displayed because 6 is already here. Okay, um, and then it comes back to the main after it executes the whole body of the display value and then executes whatever in the main function from the code. Okay, so this is actually the sequence how it comes. All right, so going again, so this is actually what it comes. I mean, like what this example tells. So the order we have just talked about it just now. So first it actually executes the main and then goes to the void. I mean, like not void, whatever function is being linked here, and executes it. Okay, so function prototype. Okay, just now I have been telling you that we have to put this function here in the beginning. Why? It's because something it is actually following the same terminology as what the variable used to be defined, meaning that a function has to be defined before it is being called. What if we still want to, I mean, like this seems kind of tedious because like if you're dealing with like more than one function later on, you need to make sure that these functions has to be placed before they're called. Imagine that we have understood that even here is that functions are calling other functions, right? So it's not necessarily to be, I mean, like functions to be called within only the main function, meaning that the place of call here may differ, either to be in the main function, or maybe or maybe you want to call another function. Let's say that this is void function, uh, void name here, and then you want to display. I mean, like you want to have another. I mean, like some code here. Cout um, Ali, for example. Let me just make it very simple. Okay, so imagine that here you want to display that the value of this function here. It is possible also. Okay, it is possible. So meaning that, so I mean like having this, I mean like these functions has to be defined. So if you want to display it here, even this function has to be defined and moved up before it's called. Even if you want to display it, I mean like in the main function, it has to be placed even. I mean like it has to be placed in any place but before the function that is being called. I think this is very tedious task unless we have unless we have a visible solution to help us to do that. So then we have what we call actually the function prototype. The functional prototype here, it solves the issue of ensuring that the function has to be placed entirely before it's called by actually by having what we call the creating its function prototype. So each function has a prototype, and the prototype, it is just a piece of code, or it's a line of code that actually tells the compiler, yes, before, I mean, like at the beginning of the document, at the beginning of the program, there is actually a lot of there is actually a number of functions in this program, and these functions are 1, 2, 3, 4. So it seems that something like the attendance list. So the names of the functions and what information, I mean, like what parameters they have, and the type also of the function. All right. So it is a way to notify the compiler about the function before the function call. So it is placed before, I mean, like the place function definition before the calling function definition. So this allows creating a function even after the main or any place in the program, and it also uses a function prototype. We call it also a function declaration. This is another term to describe the function prototype. So here, so this is the prototype. and this is the function heading. So the function prototype here typically adds the function heading, but we add a semicolon. Then, all right, so in this example, if we want to create a function prototype, of course, here, let me even add you this note here, is that the function prototype can be done to any function other than the main function. Only the main function that doesn't have a prototype. Why is that? You may ask yourself this question. It is because as simple as this, the function, I mean, like the main function doesn't need to be defined because by default, it is the first function that the compiler will assume that it's existed there and it must be existed there in order for the program to be executed. So imagine that if we have x, for example, and we want to execute this compiler. See, there's no main function here. There is no main function here. All right, so after fixing some errors here in the code, let me just paste that. I want to show you that here. Anyway, so also there is actually I mean like there should be a main function here, but the main function doesn't exist. See, that's why here each program, if you don't have this main function, for sure it will not be executed, as you can see here. All right, so now to write a function prototype here, in order to write a function prototype, all you need to do here before, I mean like just right after using namespace std, and this is the place where the function prototype is being defined. So defining um, now function prototypes. So now the first function here doesn't matter, the arrangement it doesn't matter, the order doesn't matter, as long as all the function names other than the main function is there and existed. So how to write a function prototype is just simply by using the whole function header. So we use the whole function header and we add a semicolon right after it. And then here we use the whole function header and we add a semicolon after it. Okay, so now see this. So before this, if you remember just now, I have mentioned that the function here has to be defined before the main, because of course we need to define it before we use it. But now let me just cut the main function here and paste it in the beginning to tell you that okay, so this is actually the main function, and it seems that even now actually there is even another function called name here that actually needs to be called. All right. So, okay. So displaying this, I mean, like having this code in this way, it will make the program run with no errors. Why? It's because now the compiler has a prior information about what are the functions that are existed there. So we call this as a I mean, like as a function. We call it as a function declaration. So we are declaring a function before we are using it. So clicking here, see, it actually performs the code with no errors. So even I have the new function code here has been displayed as Ali, and you need to note that. So you remember, say, let me just execute it and show you the thing I want to declare, the thing I want to clarify here. All right, so goes to the main function, executes the first statement, and then goes to the first function here. So no matter where is this function placed to be in the beginning, I mean like to be before that, I mean like the functions to be before each other, but the important thing here is the order of the functions in the main. So if you want to have, I mean like if the question is asking you to display something like this while displaying Ali, for example, from a different function than the, I mean like the other function that displays I like programming, of course you need to execute, you need to call that function before calling the function name. Meaning that, so the order of the function call, it will affect the order of displaying the output here. This is very important note here that you need to take care of. And then after the compiler finishes executing the functions, other functions, it turns back to the main function and execute the rest of its code, which is this display. I'm back to the main function. All right. I believe this is actually even more simple. Regardless to that, I mean, like to the amount of theory that has been described here. I think with practice everything will be, I mean, like more easier and looks even more clearer to you. So a function prototype here, again, it's called as a function declaration, as we have said, and I want you to notice this. So this is a function. This is a function. This is a function heading. This is a prototype, and also the third one I want you to differentiate with is that this is a function call. So we have three terms that you need to differentiate between, like regarding the function. This is, we call this function call. And function call, it's placed, the purpose of the function call here is to execute the body of the function. We call this as a function prototype, and this is the way how we write it. So function call differs from the function prototype by is that a function call doesn't include any type, any return type. So we cannot write void here. This is wrong. Okay? It is because this one is a function call. Okay? All right. So function prototype here, it is the declaration of the function, and it is used to tell the compiler that there is a function that can be executed, and it's existed within the program. And this is the function header, and it's exactly same as the function prototype, but without the semicolon here. And the function header, of course, it defines the function. It's placed in the beginning of the function before it is code, and right after the header, of course, should be the body of the function. All right. I hope that these three terms should be clear to you, and you'll be able to differentiate between them very clearly, especially when you talk about that call, because I think most students are actually mixing. They're confusing a little bit between the function call and its prototype. Okay, function call doesn't take any return value. Remember this, doesn't take neither int double nor nor void. Okay, so prototype notes here that you need to focus about. So place a prototype near to the program. So nearly, so we place it, as I told you, at the very top of the program. Most likely we place it at, like right after mentioning the namespace. So program must include either prototype or full function definition before any call. So either we just place the function prototype here, or we place the whole function here, as we have done just at the very beginning steps of writing the program. So either we just cut this and paste it before the main, or we can just write the main. But of course, this doesn't mean that we can just delete this. I'm talking about like how to execute this. Okay, how to execute name. So the body, of course, has to be existed. We cannot omit it. But here I'm talking about, in order to make this execution valid, we need to either, if we do not have prototype, we have to move this. We have to move this before, like the place of execution of the function. Of course, cannot be inside the main, because we cannot write function inside a function. And this is a very important note here. I cannot write it like this. I cannot take, like the whole piece of function here and put it, like let's say something like here. This is very, very long, and this is a fatal error. Okay, so this is, you need to take care. You need to be careful about like typing this. We cannot write functions inside functions, at least for this level of learning, I'm saying. Okay. So I hope this is very clear now to you. All right. So when using prototype, can place a function definition in any order in the source file. Of course, this is very clear, and we have just proven that. Okay. So by writing a prototype, we can use the function name. Like the function here in any place, can be before the function call, can be right after the function call, can be even at the end of many functions that are being written here. Okay, so place here, it doesn't, like the order of the function here, it's not matter, it doesn't matter. But what matters here is that the sequence of the calling, the sequence of the function calls. So if this function has been called first, so it will be the first function to be executed within the main before the name. So this is to be executed, display value is to be executed before the function name. All right, so this is another function. Is actually to display, how to call first and second functions. Actually, I have been also practicing this with you here. Believe it or not, actually, you don't need to. I don't need to repeat it again. But let's just theoretically or like roughly go through it, because we have typically written the same code as here, just the different with the different purpose of see out to say or display. All right, so from the main here, after we have written, this is the function prototypes, as you can see here. So function prototypes, again, it only being performed for the functions other than the main. So main doesn't has a prototype. Okay, so we write the function prototype. Remember, you need to use the return type and then the function name followed by finally the semicolon. And this is how it differs from the name of the the function header. This is the function header, this is the function prototype, and this is the call of the function. So under the main here, you can just write, like for example here, see out. you're displaying this, and now you want to read from the main function, the first function, so you call it. So the call of the function makes the compiler going to the first function and then execute its code, going back again, and then entering the second function, executing its code, and then going back into the main function. And this is how you will see. All right, so now we have actually another topic, and this topic is really interesting. So now we want to make the function actually like being more dynamic and have more interaction with each other. Meaning that how can we send data into a function? Let's say that okay, sometimes you are just like calling the function here from the main. But what if I want to like pass some data here. Let's say for example I want to pass the value 4 and I want the name actually to handle the value 4 here in order to use that value within the function body. Okay, so we pass data into the function in order to allow the function to use this data. For example, I'm passing data from the main and I want the function to make use of this data within the body. It doesn't matter what kind of data, as long as of course, the passing of the data it depends on the purpose of the function. So, for example, the function that display a name, I cannot pass the data just like this for the purpose of passing data. Of course, it has to has a meaning. So let's say we are actually using the function that is actually, like for example, sum here. All right. So you want to pass a data, that it's actually for, okay, fine, let me just use the same function. I do not want to change the structure too much here. I will just change the name, like the data that to be passed here. So passing data here, it's just to enter a value, like something like Ali, for example. Okay. All right, so we are passing this data here, and in order to receive the data here, we need to have what we call a parameter here. Let me just, before getting into, into the practical, let me just go back into the theory and review the slides, and then we can just come back here. But passing the data, it is about like sending the data in the call to be used in the body. All right. So until here, I think it should be clear. Okay, so values here are passed to the function are called arguments. So these are called arguments. So Ali here is called Ali is called an argument. All right. So variables in the function that holds the past arguments are called as a parameter. So of course, now like this, you need to understand it. So whatever value or whatever argument has been passed in the function call, it has to have a corresponding variable. So the variable here it's just defined as any variable, string, name. Because of what? Because actually this variable, it will receive the value here. You see, this is actually another way of assigning values. You remember that we used to assign variables as the normal way by like writing string, for example, name equal to Ali, and this is the very traditional way that we used before, if you remember. Or we can read it from Cn, for example, name, having name being defined as, as a string only. Okay, so these are, if you remember, these are the two methods that we have learned how to, how to assign values into the variable. But this is another method now. But this kind of method, it's only used for functions. So it is to pass data between functions. So in order to pass data, so we write the value here in the function call, and in order to receive the value, so we receive it here. We call this as an argument, as you know, and then name here. Name is called as a parameter. Okay, so each argument has to have the corresponding parameter, and this is number one. Number two, the parameter type. The parameter here is a variable. The parameter here is a variable, and that variable type has to meet the same type of the passed value. Meaning that if like I'm passing Ali as a value here, of course Ali is actually corresponding to a string. I cannot define it here as a char, for example, or I cannot use like int name. This is very wrong. Why? It's because name, the type of that variable cannot store this value here. Okay, so it has to meet the type of the passed value. All right, so let's just go back again. I will just actually go bit by bit with you because I'm trying to link the theory first and then I will go into the practical because it's much better actually to translate all these kind of statements into like what in actual programming they can be affected to because later on of course this is what you will need to implement rather than like only memorizing these kind of concepts. All right, so alternative names here for the argument here. You can call argument as an actual argument, actual parameter, and parameter can be called as formal argument or formal parameter. And I'm telling you from now, actually, I will not be using these even in any of your assessments, but it's just for your knowledge. But what I will be using with you is that argument here, it is the I'll be using argument and parameter because I will be defining this as an argument and you should know that this is actually the parameter because even these two names are the most famous names for argument and parameter. All right, so like for example here, so display value. Let's just take this as an example. Um, all right, so display value here. Let me just. All right, let me just delete this. I'll just go with this as simple as possible. All right, so now we have this. We do not need to have a name here. And I will implement this here again. All right, so if I want to display 8, display value, so I'm passing the argument here. So what is the argument here? It's 8, the value 8. It's being passed as an argument. All right, so now under the function, here I should actually define a corresponding parameter. So the corresponding parameter, since I'm passing 8, so 8 is a numerical and it's an integer parameter. I can also pass it in a double, but actually it's more proper to pass it in a integer since it doesn't has any kind of floating points. All right, so int num, it doesn't matter. So this is the variable name. Doesn't matter to be like any specific name. You can use num x, y, z, number, value, whatever name you want to use. Important thing here is that to match the type with the type of the value. And then here you can just simply type the value is, for example, the value is what? Is num. See? Now I'm using num. Why? It's because num here it's actually defined. I don't need to define it like int num again. This is very wrong. This is actually wrong. Why? It's because num it's already been defined here, and this actually happened to be within. I mean, like the scope of this variable. Also, its scope here. It's the whole body of the function. So you don't need to define that variable right again. You just need to use it. So now, what is the value of num here? It is 8. Whatever value is being passed, so this will receive the value, and now I'm using, I mean, like displaying the value. So let's just display this, and you can see. All right, so display value here, void display value 8 and num. It shouldn't have any problem. Oh, yeah, I'm having an error here. It's because, yeah, this is related to the prototype now. This is related to the prototype. All right, so the error here is that you need to define, okay, because we have said that the function header, I mean like the prototype here, it is typically same as the function header, even including its parameter list. And this is a new update that you can add to the difference between, I mean like to how to create the function prototype here. Since now we have a parameter list, we have some parameters in the list. Before that, we learned that we do not have any list, so that's why we don't need to care whatever, I mean like what are the values between the two brackets here. But because now we have the same, I mean like we have a parameter list here, we need to copy exactly the same parameter list. So even with the type of the parameter, even with the name of that parameter, all right? So with that, we can actually execute the code with no errors, as you can see here. So now you can see, so the value here is, let me just not to add this, I just want to I just want to execute this alone, okay, because I do not want to make any confusion. All right, so in the main here, I only have the call of the function. I do not have any kind of other statements here. So once you execute that, so the value is 8. Okay, so the value is 8 here. So how does that happen? Is that number 8 has been passed into that function, and then the function has received that value in a parameter that it's called num, and its data type is already same as the data type of the received value. Okay, and now I'm using to display that value. Even I can use it in any calculation later on if you want to use it, like to say like int x equal to num plus 3, or int, for example, equal to y. I mean, like using the variable itself in any kind of calculation you can do so. Even you can actually change, like saying that num can equal to, for example, 4. Okay, and in this case, this is even a point that I will tell you later on. Okay, that you can even change its value with no errors and no mistakes. So here it displays the value of 8, which is the value that has been received. If you want to execute this again, you can see even now the value is 4. Why? However, you are passing 8 because you have already updated it before. I mean, like before the display. As long as you have updated the value before displaying it, so it has reached, I mean, like the value here is the updated value that has been set to 4. All right. So this indicates that you can actually manipulate and use the past value in a different in more than like one way to display. All right. So a function with a parameter value variable. So this is the function. How is it displayed? As we have explained just now, of course, it has to be an integer, as we have mentioned, because this has to match same as the data type of the past value. And then, of course, so parameters. So this is, I mean, like like the integer value has to match with that function. All right. So parameters, prototypes, and function headings. So this is just a revision, or like just to for each function argument. So it has to have the prototype must include the data type, as we have mentioned. So this is actually how to differentiate. I mean, like for any kind of function, in order to write a prototype for the argument, it has to have the data type of each argument and its list, for example, this one, and also has the heading, for example. So actually, I want to tell you also one thing here, because you see in some styles of C++, some of them they are writing the prototype to be like this. If you notice, we do not have any value or like any parameter name beside the data type. See, just now we have executed this, and this is valid. And also, there is another way of writing a prototype is that you don't need to write the variable name. It's just the minimum thing that you need to mention one type of the parameter is being passed here. And for example, and by the way, order here is very important. If you have more than one argument, if you have more than one parameter here, okay, of course you need to have I mean, like you need to have them being written in order. So this is int and this is another int. So if this happen to be double, so this has to be double and it has to be in order. Okay, so it has to be in order. So anyway, my point here is that whenever you want to write a prototype, there is two ways actually. Either to make it like this, and this is the minimum way to write a prototype. I mean like by omitting the parameter name. I mean like the parameter name. Okay, and this is valid. If you executed this, it still works here, and with no errors. Okay, it still works with no errors. This actually because I have terminated the terminal in gracefully, actually, not in a graceful way. Okay, so this is the first way. The second way is the way that we have been just now is to write the parameter name. So both ways are actually working in this. Okay, and function heading, it must include the declaration with the variable and the type and the name for each parameter list, as we have mentioned here. Okay, so function call, of course, it has to have the value that we are passing here. It shouldn't have, this is the function call. So function call doesn't include the definition of the variable, meaning that a function call here, it has the value that we want to pass. So we cannot like write a function call as int x. This is wrong. This is very wrong, okay? Because in this case, this is not a function call, because this is the place where you want to pass a value. You can write x. Okay, by the way, you can write x, and later on we will learn about this. I will not actually teach you this. But x here has to be defined before, I mean, like in a place before, x here has to be maybe equal to int x equal to 3, int x equal to 4, and then you are reading from x. Okay, but for the time being, let's just know that we